Hello, Mr. Claxton's Algebra 2 class. Just wanted to discuss with you completing the square, solving quadratic equations, rather, by completing the square. What we talked about to start the day was to list all the different ways that one could ask you to solve a quadratic equation. And I'm going to ask you to pause right now and take a look at this if you are watching at home and would like to take notes. I am just going to make mention of the fact that we can use the quadratic formula, but we do not know how to use that yet. We are going to prove the quadratic formula by completing the square. After that, we will be allowed to use the quadratic formula. We've learned how to solve by factoring already. With factoring, there are some special cases that we need to consider first, such as the difference of squares. When we have the difference of two perfect squares, which is a squared minus b squared, when you see two perfect squares being subtracted, you know that's going to factor into the quantity a plus b times the quantity a minus b. I'm kind of going backwards here. If you did FOIL and simplify, you would get to a squared minus b squared. Then we have the perfectly square trinomials. We have a plus b squared. When you square that term, you must expand. Understand the intermediate step here is expanding this to be a plus b times a plus b. So if you're looking at it here, if we can go ahead and turn on the Mobi, what we're really doing first is we're saying a plus, Mr. Claxton, that would be a plus b, not x plus b. Let's get your mind in the game, right? So we'll go ahead and erase that. So a plus b times a plus b. You know that if we did FOIL this, then that would take us back to the simplified version right here. And essentially, what I want you to see as a teacher is I want you to be able to see something of this form, and then notice right away that that would factor into a plus b squared. For example, one of them would be, an example would be x squared plus 10x plus 25. And I think you could give a great guess at what that would factor into. Down here, we have a squared minus 2ab plus b squared. We know that when we see something of that form, that is going to factor into the quantity a minus b times a minus b, which is just the quantity a minus b squared. We can also factor by grouping. I did an example on the board today for factor by grouping, where we started with, I'm going to go ahead and show you this. We started with 12x squared plus 10x minus 12. So when we start with something what a trinomial such as this, we can see that in the three terms, they all share something in common. So I can make it just a little bit easier on myself by factoring the common factor out of all of those. Of course, if we were to break all of this down, we would see that the common factor is 2. So again, I want to divide all of this by 2, and I have to counteract the fact that I'm just dividing by 2 because I don't want to change the value of that expression. That entire expression, I don't want to change the value by dividing everything by 2, so I have to counteract that by multiplying that entire expression by 2. That's just called factoring out a 2. So I know that I can divide each expression by 2, and it's going to leave me with 6x squared plus 5x minus 6. So looking at that right there, decrease the quantities just a minute amount, a very small amount there. So what we're looking at now is we're looking at this factor by grouping method, and if you remember, the first step is to multiply those outer terms of the expression. So we're going to go ahead and multiply the coefficients of those outer terms. We are going to multiply positive 6 times negative 6. When we multiply positive 6 times negative 6, we know that we get negative 36. So now we're looking for factors of negative 36 that have a sum of, oh boy, lost my train of thought there for a little bit. Factors of negative 36 that have a sum of 5. So we want them to have a sum of 5. So I'm going to go ahead and write that here. So if you are taking notes, make that a little bigger. Looking for factors of 36 whose sum is 5. Actually, I want to say negative 36. And that's a sum of positive 5. I want to make sure that's a sum of positive 5. So when we're looking at that, when we're looking for those factors right here, which I'll go ahead and mark here in a different green color, you know that 6 times, or 6 plus negative 6 would give you 0. Other factors of 36 are 9 and 4. So if I go ahead and break it down into, and I don't know why you would do this, negative 9 times 4, I know that negative 9 plus 4 is going to give me a negative 5. And I want a positive 5 because I'm looking for the coefficient with that middle term, what we call that linear portion of our quadratic. So obviously I just want to switch the signs on those, 9 and negative 4. And I know that 9 times negative 4 is negative 36. 9 plus negative 4, on the other hand, is positive 5. So I've found a winner. Because I've found that winner, I know that I am going to split up that 5x into 9x minus 4x. Or you could say 9x plus negative 4x, I guess. If you did say 9x plus negative 4x, it might make sense. The next part of this might make sense. So when we call that 9x plus negative 4x, understand I still have the 6x squared out here. Still adding that 9x. And I still have that minus 6. And of course, that was all inside a quantity that was multiplied by that pesky factor 2 that we factored out earlier. So now comes the factor by grouping. I'm going to go ahead and group together. We'll go ahead and use blue for that. I'm going to go ahead and group together. Again, we have parentheses inside parentheses. That is okay to do here. The first two terms and the second two terms. And understand, when I group them together now, I'm going to have to factor out, or I would prefer to factor out a negative, and you'll see why that is here in a little bit. So now I'm going to have 2. I'm going to multiply. I'm going to go ahead and put brackets now, just to kind of change it up a bit. They mean the same thing. They're all grouping symbols here. Let's not get excited about this. And probably didn't want to put that there. I do need to check my time down here. I can see I'm at 8 minutes and 34 seconds, so I need to finish this up very, very quickly so as to not to be able to post it to YouTube. I'm going to go ahead and factor a 3. I know I can factor a 3 and an x out of that first one. So I'm going to factor that 3x. Mr. Claxon, just call it 3x. Alright? When I factor that 3x out, I'm left with 2x plus 3. So what I'm trying to do is I'm trying to get that 2x plus 3 to appear over here. In order to do that, I want to factor out a negative 2. So when I factor out that negative 2, I call that plus. I'm going to call this negative 2 multiplied by 2x. This is the special part here. And I want to call this plus 3. The reason why I want to call that plus 3 is because when I multiply that negative 2 times the positive 3, I want it to be a negative 6. So that's why I had to call it a plus 3. In addition to that, it helps me out very much because I now have a common factor. You now see that the common factor between that first term, okay, which would be the 3x times the quantity, after there's that 2x plus 3. I can factor that 2x plus 3 out. So I'm going to go ahead and do that. When I factor that 2x plus 3 out, what does that leave me with? It leaves me with a 3x minus 2. That 3x minus 2 there in blue. 3x. And that says plus negative 2, and we all know that that just means minus subtract 2. And I must not forget those brackets around the outside multiplying by 2. So the reason why this is unique is because it allowed me to factor. If I wanted to find the zeros, understand I could go back and set these equal to 0, but I'm not going to talk about that in this episode because this was a factor by grouping example, in addition to other special factoring cases that we have talked about already. You should be prepared for this on a quiz or a test.